since November 15th, 1995. Knowingly venting any refrigerants is a violation of the CAA. This includes CFCs, HCFCs, and CFC and HCFCs refrigerant substitutes. Only the de minimis release is allowed during service, maintenance, or repair, which refers to the small amount of refrigerants emitted unintentionally during a good faith effort to recover refrigerants during the normal course of appliance operations or during the connection/disconnection to charge of service and appliance. Nitrogen that is used for holding charges or as a leak test gauge may be released. However, nitrogen may not be added to a fully charged system for leak detection and then released. Refrigerants, as determined by the EPA to not pose a threat to the environment, like R290 propane, R600A isobutane, and R728 nitrogen, are exempt from EPA 608, the regulations regarding releasing and venting. Other examples that are not considered refrigerants are those used for leak tracing. All CFCs, HCFCs, and HFCs must be recovered before opening a system for service or disposing of an appliance. This includes cutting a line before removing a component. CAA disposal. The EPA has a set standard for recovery of refrigerants prior to appliance disposal, including that all refrigerants in disposal containers have been recovered 0 psig or lower and rendered useless before recycling the cylinder. Before disposing of any appliance containing a CFC or HCFC refrigerant, the refrigerant must be recovered. The person responsible for ensuring that refrigerants have been removed from the household refrigerators before they are disposed of is the final person in the disposal chain. CAA phase out, venting, and disposal review questions. When was the CFC phased out date? Number 2. When was the HCFC phase out date? Number 3. For servicing of older systems, where do CFC refrigerants come from? Number 4. Are technicians allowed to release nitrogen into the atmosphere? How about a mixture of nitrogen and refrigerant? Number 5. What must be done before scrapping a refrigerant container? Number 6. What must be done before disposing of an appliance containing CFCs or HCFCs? And number 7. Who is responsible for removing refrigerants from a system that is being disposed of? Refrigerant oils. Due to the change in refrigerant use, you may encounter new refrigerants, old refrigerants, and blends of older refrigerants, as well as different oils in the field. Taking oil samples may be necessary and is a good maintenance practice when discovering a leak. Mineral or petroleum oils include paraffin-based oils, naphthalene-based oils, and mixed oils, a combination of naphthalene-based and paraffin-based oils. Synthetic oils include synthetic ester, silicone, neopentyl ester, dibasic acid ester, polyglycols such as polyalkylglycols (PAG), alkyl benzene (AB), and polyolesters (POE). Synthetic oils must be stored in metal containers. Ester oils are generally used with alternative refrigerants and are typically compatible with mineral oil and existing system components. Refrigerant oil must be miscibles at low temperature, lubricate even when it is diluted, have electrical insulation properties, maintain its stability, and provide a pressure seal. For these reasons, the minimum evacuation must be 500 microns before charging when conducting a major repair on a HFC system using POE oil. Oil properties. All refrigerant oils have certain proportions and properties in common. For example, all refrigerant oils are hygroscopic, meaning they attract moisture. The viscosity of an oil refers to its thickness, while the density of the oil refers to the composition of the oil at a given viscosity. An oil's stability is its ability to lubricate without chemical breakdown, while its solubility refers to its miscibility with various refrigerants. Solubility of air refers to the air and moisture entrainment capacity of an oil. Miscibility refers to the ability of an oil to be mixed, while low temperature miscibility refers to the oil's ability to not separate at a low temperature. Foaming refers to the tendency of the oil to foam when it is subjected to pressure changes. Foaming will reduce the oil's ability to lubricate. The dielectric strength of an oil is the threshold at which the oil conducts electricity. An oil oxidization value is the ability to resist sludge accumulations. Its boundary film forming ability is its ability to separate high pressure and low pressure. There is no drop-in replacement for refrigerants for R12 systems. Substitute refrigerants. All replacement refrigerants require additional retrofit procedures. New refrigerants are incompatible with the oils and lubricants used in R12 systems, and therefore oils must be checked and changed out as part of the retrofit procedure. R134A, also called HFC 134A, is a leading replacement option for retrofitting R12 systems. With the advent of the HFOs, R1234YF has become the best alternative for R12 and R513A for R134A, at least in terms of ODP and GWP ratings. The oil must in most R134A systems are ester-based oils, and ester-based oils do not mix with other oils. Leak check an R134A system using pressurized nitrogen. R22 and R410A cannot be mixed together, whether it is for topping off, leak detection, or substitution. These refrigerants operate at different pressures and therefore require different compressors and higher pressure components.